In this video, I'd like to talk about the idea of finding the area of a circle. And finding the area of anything is essentially just asking how much space that object takes up, or how much flat space the object takes up. So we're dealing with two-dimensional shapes like rectangles, squares, triangles, or circles, and asking how much the inside of that shape actually takes up. And with rectangles, squares, triangles, or parallelograms, they're fairly straightforward and can be calculated using various formulas that make a lot of sense. However, when dealing with the circle, it becomes a lot more complicated because we have a curvy shape here. So let me briefly explain that idea by making a little bit of room here. So if we have some general circle, let me just draw one in very quickly. And we want to find its area. So remember that when finding the area, we are essentially figuring out how many tiny boxes we can fit inside of a specific shape. So remember for a rectangle, and actually let me use a different color for this. For a rectangle, let's say of length 4 and width 3, we would split this rectangle up into a bunch of 1 by 1 boxes. And these 1 by 1 boxes, we can say it's 1 unit by 1 unit. These boxes have an area of 1 square unit. And we're trying to figure out how many of these unit squares we can fit inside of our shape. So with rectangles, we can split them up into these 1 by 1 boxes and essentially just add them up. So we split this side up into 4, we split this side up into 3, and it's not drawn perfectly to scale. But the general idea is that each of these lengths now is 1 unit. And we have all 1 by 1 boxes, or we just have unit squares now. And you can count that there are 12 of them. Or you can remember the formula that you just take your length and multiply it by your width, or vice versa. So 4 multiplied by 3 would be 12, and we're dealing with square units here. Now, you might be able to see the problem with this approach and circles. Essentially, the question becomes, how do we count how many of these unit squares will fit inside of a circle, since it has these curved edges? So some of the square might fit in, some of it might not. So that approach is not going to work with circles. And essentially, we need to use ideas from calculus to really understand this. So when you're learning the area of the circle for the first time, you're generally just told what the formula is. In fact, the formula for the area of a circle is equal to pi multiplied by the radius of the circle squared. Where remember, pi is the circle number, and it's generally approximated as 3.14, but in reality, it's an irrational number. It has an infinitely long decimal expansion that doesn't have a pattern. And in this formula, r is just the radius of the circle. That's the distance from the center of the circle to the edge of the circle. So using pi and knowing the radius, or if you know the diameter, you just know the radius is half that, you can find the area of the circle. And again, the question becomes, where does this formula come from? And like I mentioned, to really understand that, you need the ideas from calculus. Since effectively what we'll do in calculus, if you do make it that far, is you're still going to use a similar idea to this, though instead of using squares, you will use small rectangles. So I'll just give you a general idea very quickly. And let's just focus on one sector of this circle. We'll just look at this top fourth of the circle, and in reality, we can just find the area of this and then multiply it by 4. And what we would do in calculus is essentially cut this sector up into a bunch of tiny rectangles. So maybe we'd start by making just 4 rectangles, or maybe 5, depending how we're going to draw this, where all of the rectangles have roughly the same width. This is not going to be drawn perfectly to scale. These should all be the same width. And you can see by approximating this with rectangles, it gets fairly close to covering the entire sector, but not exactly. So maybe we use 5 this time, but if we use more rectangles that again have the same width, it's going to more closely approximate the sector of the circle. So let me show you what happens if we use more of these. So you can see in this case that I've used 13 different rectangles, and you can notice that they approximate the area of this sector much more closely. It's still not perfect. You can still see little gaps, and if we zoomed in, you could see them even better. But it's closer than when we just use 5 rectangles. So in calculus, what we do is we would make these rectangles smaller and smaller. In fact, we would make them essentially as small as possible. It's a little bit complicated, the details of that, but the smaller the rectangle, the better that it approximates the area underneath this circle to this line essentially. And with all of those rectangles, then we could just add all of them up, and that would give us the total area of this sector of the circle. And then of course we can multiply by 4 to get the rest of it. And if you apply those ideas, you will get this formula. Now, the ancient Greeks were the first to really discover this formula. They did not use that idea. They essentially figured it out with a different method, but that's something I can cover in a different video. But the main idea is that it's difficult to get this formula. So typically students are told what the formula is, and if they go far enough in math, they will be shown how this formula is actually derived. So for the sake of this video, we just want to focus on how to use the formula. And if you go far enough in math, you can learn where the formula really comes from. But it does, or at least one way of getting the formula, does come from essentially cutting it up into small rectangles and then just adding them up, since we do know how to find the area of a rectangle. So to answer this specific problem, we are told the radius, and we're told the approximation for pi, this 3.14, and we can just plug in those values to our formula to find the area of the circle. And it's not going to be an exact answer because we are approximating pi, but we can get a rough idea. So the area of this circle is pi, this 3.14, multiplied by the radius, which is 5 squared. And if we square 5, that's just 5 times 5, which is 25, and 25 multiplied by 3.14 is 78.5, and since this doesn't have a unit, we can just say this is square units. And really, we should be careful. This is the approximate area, since we are using the approximate value for pi.